Okay, here's another video on simplifying trigonometric expression. So you remember the idea, express everything in function of sine and cosine. So I need to simplify this expression. Alright, well, let's see. So it's going to be equal to what? Cosine x. Well, that doesn't change, right? 1 plus sine x. And here we have sine x over cosine x. This is what tan is, right? Okay, what do we do with this now? Well, I think I'm going to do a common denominator, right? So I'm going to multiply both sides of this fraction by this denominator, by cosine x. And both sides of this fraction by 1 plus sine x. This is how you get a common denominator, right? Okay, so here we go. 1 plus sine x. Okay, let's see. What do we have now? Let's see. So we have cos times cos, that's cos square x, plus, and I'm going to write everything under one denominator, right? Yeah. So at the denominator we'll have sine x times cos x. Okay, let's distribute that, plus sine x, and here plus sine square x, right? Okay, it's my experience that it's never actually it's never a good idea to expand the denominator right here, so I wouldn't expand that. I would leave it in a factored form. Okay, if simplification, if you can simplify the fraction somewhere, then you will be able to do it when the factor is when the denominator is factored, not if you expand it. Okay. Okay, so what can I do right here? Well, let's see. I'm not sure, because you got the sum at the top, and of course nothing is going to simplify. These are terms. They are not factored, right? They are terms. So I got to change that. But when I look at that, I'm not sure exactly. So you look at it, and then you should be able to recognize this cosine square plus sine square. Well, this is not algebra. This is a trigonometric relation. This is 1, right? So it's 1. What's left? Sine x at the top, right? Divided by 1 plus sine x times cosine x. Okay, what's going on here? Well, what's at my numerator? 1 plus sine x. This is one term, right? I mean, it's a sum of two terms, but that's what I have at the numerator. And look at it here. 1 plus sine x, it's a factor of the denominator. So the term 1 plus sine x, the factor 1 plus sine x is at the top and bottom. You can simplify it, and you're left with 1 over cosine. And 1 over cosine is just secant x. Alright, so this is what's going on in the first simplification. Let me show you a second one. Right here. So this time, let me make it a bit bigger here. This time, I am given the second side. I'm supposed to show that the first side is equal to sine plus cosine. It's kind of interesting. Before we do anything, look at what's the numerator. Cosine plus sine. Okay, so it seems like I should be able to cancel the denominator. Of course, it doesn't really work like that, but it's kind of interesting to notice that, I think. Alright, let's see. So I'm going to take my left side, and I'm going to express, oh, that's red. I'm going to express everything in function of sine and cosine. So what do we have? Cosine x at the top, and here we have 1 minus sine x over cosine x, right? Okay. Plus sine x over 1 minus, so here it's cotan, so it's cosine over sine. Okay, alright. So hopefully I'm going to write a series of equality, you know, some stuff, and then more equality, some equality, and some equality. And hopefully at the end, I should be able to find that, right? That's the idea. Okay, let's see how that's going to work. Well, here's what we're going to do. I usually don't like to get a common denominator when I have a fraction over a fraction like that. I like to get rid of my denominators right away. So I'm going to multiply here both sine by cosine, and for this one we're going to multiply by sine both sides, so we'll get rid of the denominator, right? We're going to multiply by sine both sides. Okay, let's see what we have. So careful, that's not a common denominator between the two, okay? So I'm not going to write one fraction bar here. We have a cosine square over what? Over cosine x minus sine x, right? That's what we have. Cosine x minus sine x, right? Because when you multiply here, you gotta distribute this and then distribute that, and then the cosine will cancel. That's what we wanted. We wanted to cancel the fraction at the denominator. What do we, oops, it's on equality here, it's a plus. What do we have on the other side? We have a sine x, sine square x, divided by what? Well, this time it's sine minus cosine. Well, look at the denominators. Cosine minus sine minus sine. So hey, you know, what's the relation between a minus b? Algebraically, what's the connection between a minus b and b minus a? Well, these quantities are called, in algebra, they are called opposite, right? Opposite. If you multiply a minus b by -1, you're gonna find b minus a, right? So this is opposite. All right. So well, it's easy to add two fractions when the denominators are just opposite. Here, let me exhibit that actually the denominators are quasi the same. Check it out. I'm not changing this one, and right here I'm going to take a negative sign out. You know, I'm going to take a negative sign, I'm going to put it in the front of my fraction bar, so you have sine square x over cosine x minus sine x. Okay, again, what did I do here? Could I do that really? Well, yeah, look, check it out. When you have a negative sign at the bottom, you can put it wherever you want to. You can put it at the top, or you can put it in the front. Okay, this is basic rules in dealing with fractions. You should have known that before algebra, before pre-algebra probably. Okay, all right, so now that I have my common denominator, well, let me just subtract. Okay, so cosine square x minus sine square x over cosine x minus sine x. Now I don't know if you see it right away, but now there's one last step, and it's an algebraic step. And if you don't see it, then look, in algebra 1 actually you've simplified things like that. You've simplified things like that. It's exactly what I have right here, except that instead of a and b, I am dealing with trigonometric function, okay? But this is just algebra 1 stuff. What do you do right here? You factor the top, okay? You just factor the top. Because actually the bottom right here, the bottom, I know the bottom is a factor of the top. How so? Well, look, how do you factor a difference of square? Cosine minus sine times cosine plus sine divided by cosine minus sine. That's what I was saying. I was saying the denominator is actually a factor of the numerator. You see right here? It's my denominator, which is also, I mean, it's a factor of the numerator. So now here we go, we do this, and we have just landed on cosine x plus sine x. Now, what's going on here? Well, that's just what I wanted, right? Sine x plus cosine x, and I have cosine x plus sine x, which is the same. So I write at the end of a proof like that, when you're given a right side, I always put q e d, and it's Latin, that means quod erat demonstratum, I believe. I'm gonna try to spell it demonstratum. Maybe there's an O right here, I don't know. And it means what was supposed to be proven, basically, okay? It's very typical in math to write QED, quod erat demonstratum, what was supposed to be proven, what I wanted to show, okay? QED. But the QED is not specific to math, you can use it in everyday language with your friend QED. Alright, I'll stop right here.